Hi guys, so today we are going to be talking about binomial expansion, okay? So why do we need to learn binomial expansion? That is because in lower sec, if you have a algebra expansion with a square term, it's going to be quite troublesome, like you have to rainbow it out, okay? And if you encounter a algebra expression with a cube in it, then you will need to split the term into 3 brackets before you fully rainbow all 3 brackets out. So that is very troublesome, okay? So we are going to learn binomial expansion to make this process a lot easier. So let's start by taking a look at type 1 question. I dub this style of question testing your eyesight, because if your eyesight got problem, then you're going to have issues with this type of question. The question begins by saying, can you expand this 3x minus 2 over x squared to the power of 8 to the first 4 terms? So what are we going to do? We are going to refer to the formula sheet. So the formula sheet, right on top of the formula sheet, there is the expansion technique for binomial expansion. So we just need to follow it one by one, okay? But if you do not want to refer to the formula sheet, then listen to what I'm about to say, all right? So the first term of the binomial expansion is you take the first guy, which is 3x, and put it to the maximum power. So we're going to put it to the power of 8. Then the second term onwards will follow a very strange pattern. All right, so I like to write all my terms, right, in a 90-degree fashion. A lot of school teachers like to write the terms one after the other. Not me, I like to write it in a 90-degree fashion so you can see the transition, all right? So the second term, we are going to write 8, 1, where 8 represents the power, and 1 is actually the position of the term. Okay, so we're going to explain this a little bit more in detail later, so don't bother about it right now. Then the second thing you're going to write is the first term, which is 3x, used to be to the maximum power 8, right, previously, but now it will decrease by 1. So now it's going to be 3x to the power of 7. Then the last thing you're going to write is the second term, which is the minus 2 over x squared. Bear in mind, you have to include the negative sign here. We are going to put minus 2 over x squared to the power of 1. All right, so if you are doubtful of yourself, please make sure that the powers add up to the original power of 8. So if you take 7 plus 1, right, you're going to get back the original power of 8. Next will be the third term. So the third term, we're going to write 8, 2. So you can see the transition. It used to be 8, 1 previously, and now it is 8, 2. Then the first guy, which is 3x, now it's going to decrease the power further. So instead of power of 7, now it's going to be power of 6. And the last component, the minus 2 over x squared, used to be a power of 1. Now it would increase to a power of 2. Finally, we're going to look at the fourth term, the final term. So the final term will start with 8, 3. So previously it was 8, 2, now it's 8, 3. Then the 3x term used to be a power of 6. Now we'll decrease it one more time. So it's going to be a power of 5. And then the minus 2 over x squared is going to increase its power. Last time it was 2, but now it's going to be a power of 3. So we're going to stop here because the question only asks us to expand to the first 4 terms. But if you're curious how many total terms are there, you look at the original power. The original power is 8, right? So we add 1 to it. That means that the binomial expansion will have a total of 9 terms if you want to go all the way to the end. But we don't need to do it because the question only asks us to the first 4 terms. All right, so the next thing we're going to learn is how do we interpret these terms, right? So I have written down a way to expand it in the notes. So can you please refer to the note, please? So I'm going to explain how do we expand all of these terms using the calculator, right? And I have given an example on how to expand the third term. Okay, so refer to the notes, please. So we are going to type the calculator in 2 parts, okay? We're going to type the calculator in 2 parts, right? The first part we're going to enter is the coefficient part of the term. So what is the coefficient part? That means the number part of the term. So give an example, right? If I have a term 25x squared, the 25 is the coefficient part of the term, while the x squared is the algebra aspect of the term. So when we are going to press calculator, we're going to press only the coefficient components of the term. Okay, so who are the coefficient parts? 8, 2 is a coefficient because we can press it into the calculator. So you press 8 in the calculator and then shift divide 2. So that is if you're using the standard Casio 97 SG calculator. So you press 8, shift divide 2. Then we're going to multiply by 3 to the power of 6 and then multiply by negative 2 in a bracket square. And we are going to enter all of this all at one shot into the Casio calculator, and we are going to get a coefficient of 81648. All right, so after we settle this, then we move on to the algebra component of the term. So we're going to siphon out all the algebra terms, and the algebra terms are x to the power of 6 from the middle bracket, and from the last bracket, we have a minus 2 over x squared, right? So the x squared is at the bottom of the fraction. So we're going to do a little bit of indices. If we flick the x squared up, you're going to get x to the power of negative 2. And because there's an external power of 2 as well, so these two numbers are multiplied to give you a power of negative 4. Finally, if you consolidate all the algebra terms, you will have a power of x squared. Okay, so that is how you settle all of these individual terms, right, one by one. And if you do it correctly, you will see the full expansion at the bottom of the page. Okay, you will see all 4 terms over there. So take some time to press the calculator to get used to how it is done. All right, so next we are going to move on to the hence part of the question, the second part of the question. So this is where the eyesight comes in, okay? So the second part of the question says, hence, can you find the term independent of x in the expansion of this bracket with our original expansion? I have written down the new bracket with our standard term, right, from the first part at the bottom of the page, and we are only going to eyeball the correct rainbow expansion. So we are only going to target, right, the correct multiplication, the multiplication that we can do to get the term independent of x. Okay, so what is the term independent of x? The term independent of x is also known as the x to the power 0 term, and is also known as the constant. So indirectly, the teacher is just simply asking you which multiplication between these two brackets is going to get you the constant term. So if you look at the notes, we are going to take the 1 over 24x squared multiplied by the 81648x squared. Why? Because these two x squared terms will cancel out. You have x squared in the denominator position, and you have the x squared in the numerator position. So you'll cancel out to give you just a constant. The next multiplication we're going to use is the x over 64. We're going to take that, and we're going to multiply it by the negative 108864, x to the power minus 1. Why? Because the x and the x to the power minus 1, when they're multiplied to each other, will cancel each other out to get you just the constant. So take note, we are only going to take the coefficients and multiply it to each other. We are not going to involve the algebra at all, because that is just added complication. So just take the coefficient of each term multiplied by the coefficient of the other chosen term. Okay, so if you do it correctly, you will get the final answer of 1701. All right, so next we are going to do type 2 binomial questions, okay? So type 2 binomial questions, I dubbed this Google search. Why? Because if you take a look at the example in my notes, right, I have a task for you. I want you to find the 1 over x4 term in the expansion of 1 over 2x cubed minus x to the power of 12. So power of 12 means what? Power of 12 means if you add 1 to it, that's 13. So this binomial expansion have a total of 13 terms. So I want you to find just one term out of 13 terms, which is very troublesome if you want to do type 1. Type 1 means you're going to expand it. So it's quite troublesome to just find one term out of a sea of 13 terms. So is there a better and more efficient way? Yes, the more efficient way is to use the general formula. So the general formula you do not need to memorize because it's given to you in the formula sheet. So if you take out the formula sheet and then you look on the right side of the binomial expansion, you are going to see the general formula nested on the right side of it. So now we need to learn how to fill in the blanks. So we are going to fill in the n with the power. So the power for my example is going to be 12. And the r, we're going to leave it alone because that is an unknown that we are going to try to find later on. Now, the next thing we're going to fill in is the a to the power of n minus r. And we fill in a by writing down the first component of the bracket, which is the 1 over 2x cubed. And we're going to put it to the power of n minus r, where n is 12 again. Now, the next thing we're going to do is we're going to write out what b is. So b is the second component of the bracket, which is negative x. Now, don't forget to put the negative sign. So we're going to put this negative x to the power of r. Okay, so congratulations, you have the general formula for this binomial expansion. So what are we going to do next? Now, this is where we are going to be a bit more OCD. We are going to organize the terms. So in type 1, I have stressed that every single binomial expansion, every single term that you get, right, we are supposed to write the coefficient first and then the algebra. So that's what we're going to do now to the general formula. We're going to organize the coefficient first, and then we are going to siphon out the algebra last. Okay, so what is the coefficient parts of this general formula? We have the 12r. So if you knew what r is, you could have pressed the calculator and you could have obtained a number. Now the next one is the 1 over 2 to the power of 12 minus r. How do I get the 1 over 2? Because if you look at that middle bracket of the general formula, the coefficient part of that bracket is simply just 1 over 2. So we don't care about the x cubed at the bottom. We're just going to extract out the coefficient. So that will be 1 over 2. So that will be 1 over 2 to the power of 12 minus r. Then the next one is the last bracket, which is negative x. The coefficient part of that bracket is negative 1. So we're going to take out the negative 1 and put it to the power of r. Okay, so that would be together the coefficient part of the general formula. Now we're going to siphon out the algebra components, okay? So the algebra components start with the middle bracket of the general formula. There's an x cubed at the bottom. So we're going to flick it up using indices, and you're going to get x to the power minus 3. And we're going to put it to the power of 12 minus r. Then we have another algebra guy at the last bracket of the general formula, which is x, right? So do not leave him out. So we're going to write down x to the power of r. So if you consolidate all of these x terms using indices, you're going to get a final general formula for algebra, which is x to the power of minus 36 plus 4r. So that last general formula for algebra is very important because that is the algorithm that will help you find the term that you're looking for. Okay, so how do we do it? We are going to equate the general formula for the algebra, which is x to the power of minus 36 plus 4r, and we're going to equate it to the term that we are looking for. So what is the term we're looking for? According to the question, we're looking for a 1 over x4 term, which is in indices a x to the power minus 4 term. Okay, so when we put these two side by side, because the base is the same, they're both x's on the left and right, we can simply just compare the power. So we're going to compare minus 36 plus 4r to negative 4r. So that way, we'll be able to work out that r must be a value of 8. So once you got r as a value of 8, right, your hard work previously will pay off. So previously, we have already organized the general formula into coefficient and algebra, right? So now we have the r value of 8. We can just plug this value into our general formula for coefficient, press the calculator, and you'll get the coefficient outright. So if you do it correctly, you'll get the coefficient of 495 over 16. All right, so the next type of question, we are still in the type 2 space, but this time we're going to use type 2 technology, the general formula, to solve a type 1 style question. Okay, so take a look at the example in the notes. The example says, can you find the x squared term in the expansion of these two brackets. So the left bracket is just a normal algebra expression. The right one is the binomial expansion, which we need to do now. Okay, so how do we start? Now we start by thinking out loud, right? Now, so we need to think out loud. If you want to find the x squared term, which rainbow expansion is required? Okay, so think about it, right? We are going to use the left bracket as a hint. Okay, so the left bracket, we have 2 plus 5x to the power 4 minus 4 over x. So which multiplication with these three terms here can get us the x squared term overall? So think about it. If we want to use the number 2, we will need it to multiply by the x squared term of the binomial expansion. Then if we want to utilize the 5x to the power 4, we will need to take it and multiply by a x to the power minus 2 to get the x squared term, right, overall. Then if we want to use the minus 4 over x, we need to take it and multiply by a x cubed term of the binomial expansion in order to get the x squared term. So now our game plan is already set up already. Okay, we need to look out for these three unknown terms. We need to find a x squared guy, we need to find an x to the power minus 2, and we need to find an x cubed guy. Okay, so because we are trying to find specific terms, type 2, the general formula is going to aid us. All right, so I fast forward the process. I've already input the general formula on the page for you, and I've already filled in the n, the a, and the b. Okay, so I've already done that for you, so you'll see the general formula listed on the page. Next, we are going to organize. We're going to organize the general formula. We are going to separate the coefficient from the algebra aspect, right, of the general formula. So the coefficient parts are 6r, and then in the middle bracket, right, we have 3 to the power of 6 minus r, and in the last bracket of the general formula, we have a negative half, and we're going to put it to the power r. So all of these are the coefficient parts of the general formula. Next is the algebra components. So the algebra consists of the middle bracket, the x to the power of 6 minus r, and the last bracket, we have an x cubed at the bottom. So if you apply indices, we flick the x cubed to the top, we're going to get x to the power of minus 3. And we're going to put this to the power of r. So if you do these indices correctly, you're going to get the general formula of algebra, which is x to the power of 6 minus 4r. So according to the previous page, right, we know that this general formula for algebra is the algorithm that will help us find whichever term that we are seeking. So we are seeking three different terms, right? So we're going to use the general formula to find all three. So we're going to find the x squared term by equating the general formula for algebra to x squared. And if you compare the powers, you will get the r value of 1. Okay, so once we get the r value of 1 already, we will be able to substitute this into the general formula for coefficient, and we're going to get the x squared term revealed fully for us. Next, we're going to use the general formula for algebra, and we're going to try to find the x to the power minus 2 term. Okay, so we're going to equate the general formula to x to the power minus 2, and if you do the comparison of the power, you'll realize that r is actually equals to 2. Then we're going to substitute that r equals to 2 into the general formula for the coefficient, and you're going to get the x to the power minus 2 term fully revealed for us. Finally, we're going to try to find the x cubed term. So if we equate the general formula for algebra to x cubed, right, we will unfortunately realize that the r value that we get at the end is a fraction. So bear this in mind, people. The r values can only be 0 or any positive integer. So r cannot be a fraction or a negative number. So this time, we are very unfortunate. We did not get a correct r value. We got a fraction instead. So what does that mean? That means that the x cubed term do not exist. So we can just discount him. We can just ignore it outright. Okay, so let's go on and continue with the question. Since we already have the x squared and the x to the power minus 2 term, we can just resume type 1. We are going to choose the correct rainbow expansion to get the x squared term that the question is asking us in the first place. Okay, so what we're going to do, we're going to take the 2 multiplied by the negative 729x squared to get the x squared term. And we're going to take the 5x to the power 4 multiplied by the 1215 over 4x to the power minus 2 in order to get the x squared term as well. So once we add these two coefficients up, you are going to get the answer. All right, so the last thing we are going to do is type 3. So type 3 is actually quite rare in O-levels, okay, but we're just going to do it anyway because it might come out, okay? So type 3 questions mean we have a binomial expansion, but the power is n, so the power is unknown. So how do we find this n? So the difficulty of the question scales with how difficult it is, right, to find n. All right, so we're going to start by giving you a very simple example. So can you look at the example on the page, please? So the example says that in the expansion of 1 minus x over 3 to the power of n, given that the coefficient of x squared is 5 over 3, can you find n? So bear this in mind, people. In a type 3 question, the moment you spot the power of n, right? Remember this, a type 3 question always begin like a type 1, which means that we need to regurgitate and expand out the terms first. All right, so more often than not, the teacher will not tell you how many terms to expand to. So by default, I will just expand to the first 4 terms just to be safe. Okay, so we're going to expand this binomial expansion to the first 4 terms. So the first term is going to be 1 to the power of n, and then there will be the strange pattern from the second term onwards, right? Remember? So the second term, we're going to write n1, then 1 to the power of n minus 1, and then we're going to write minus x over 3 to the power of 1. So if you remember your type 1, there's a pattern that follows after the second term. The third term onwards, we're going to write n2, because previously it was n1, now it's n2. And then the middle guy will keep decreasing in power. So it started off with 1 to the power n, then it became 1 to the power n minus 1, then it's going to become 1 to the power n minus 2. So the power keeps decreasing for the middle term. But for the last bracket, right, the powers are going to be increasing. So it starts off with negative x over 3 to the power 1, and then it will become x over 3 to the power 2, then it's going to become minus x over 3 to the power 3. Okay, so if you do all of this correctly, right, you will get the binomial expansion as stated in the notes. Okay, so don't panic. We do not know what n is, but we're going to find it right now. So the teacher gave us a clue. The teacher said that the coefficient of x squared is 5/3. So we're going to follow that line of thought. The x squared term is actually the third term. So if you stare at the third term correctly, you're going to find out that the last bracket is minus x/3 squared, right? So that means that there's an x squared term hidden in the third term. Okay, so we're just going to extract the coefficient because that's the only thing that's relevant. So the coefficient part of the third term is n2, 1 to the power of n minus 2, and negative 1/3 squared. After we do that, we are going to address the elephant in the room. What the hell is n2? So n2 doesn't look like an algebra which is tangible for us to manipulate. So the teacher will try to flex and then she'll try to explain to you all this factorial, all this exclamation mark thing that you see in the formula sheet. But I'm not interested in all this. I'm going to teach you the direct way of converting n1, n2, n3 into an algebra form so that you can manipulate it. So take a look at the bottom right-hand corner of my notes. I have listed out how to do this. So listen carefully. N1 means that there's one thing on top, one thing below. N2 means that there are two terms on top, two terms below. N3 means that there are a total of 3 terms on top and 3 terms in the denominator position. Okay, so once you write out all the spaces, the next thing is to fill in the blanks. So if you go back to N1, right, there's only one thing on top, one thing below. You always write out what the teacher has given you. So since N1 is given to us, we just fill in with N1. Then for N2, we have 2 things on top, 2 things below. We start off by writing an N in the numerator position and a 2 in the denominator position, exactly what the teacher has given us. Then every subsequent bracket next to all these terms, right, are always one less than the previous one. Okay, so in the numerator, we started off by writing N, then one less than that will be N minus 1. Then in the denominator, we started off with 2, and we're going to write out 1 less than 2, which is 1. Okay, then for N3, remember there are 3 things on top and 3 things below. We start off with N in the numerator, and then 1 less than that will be N minus 1, 1 less than that will be N minus 2. Then we write 3 in the denominator, and 1 less than that will be 2, and 1 less than that will be 1. Okay, so this is how you directly convert all of these CD brackets into algebra form. Okay, so back to the question. So I have expanded the N2 into N bracket N minus 1 over 2. Then the middle guy, 1 to the power N minus 2, 1 to the power of anything is just 1, so I'm going to ignore it. And then the minus 1/3 square is just going to get us 1 over 9. Okay, so this is the coefficient of x squared. And if you read the question carefully, the teacher says that the coefficient of x squared is equivalent to 5/3. So we're going to equate this general formula for the coefficient to 5/3. Okay, and if we just do the algebra properly, all these are all Sec 2 algebra manipulation, you're going to get a quadratic equation. And if you solve this quadratic equation in a calculator, you're going to get an n value of 6 or minus 5. Why do we reject the value of minus 5? Is because in type 3 question for O levels or for secondary school, the power of n cannot be a negative number. So we are going to reject the n value of negative 5. Okay, so the next type of type 3 question is also very famous. So take a look at the example on the page, right? The example says that in expansion of 5 minus 4x to the power of n, the ratio of coefficient of the x squared term to the coefficient of the x4 term is 25:56. So using this clue, can you find n? All right, so since we have encountered a type 3 question, we are supposed to expand it normally like a type 1. So the question didn't state how many terms to expand up to, so I'm just going to take a blind faith and just expand to the first 4 terms. Okay, so I'm going to expand the first 4 terms. The first term is 5 to the power n, and then you're going to start the crazy pattern, right? You're going to start with n1, n2, n3, and then the middle guy is going to be 5 to the power n minus 1, decrease to 5 to the power n minus 2, decrease to 5 to the power n minus 3. And then the last bracket is going to be negative 4x to the power 1, then to the power 2, and then to the power 3. Okay, but I realized that after expanding to the first 4 terms, right, I realized that if you look at the question asks us to find the x squared and the x4 term. So if you look at the 4th term of the binomial expansion, you realize that that is only up to x cubed. So that means, unfortunately, guys, we need to do one more term. So we need to get the 5th term. So the 5th term is going to be n4, 5 to the power n minus 4. And finally, the term that we're looking for, minus 4x to the power of 4. Okay, so we are only interested in the 3rd term, which is the x squared term, and the 5th term, which is the x to the power of 4 term. Okay, so we're going to extract out the coefficient for the x squared term. So I've written it down on the left side of the page. The coefficient will be n2, 5 to the power n minus 2, and 16. How I get 16 is because of minus 4 squared. Then the coefficient of x to the power 4 would be the 5th term, and the coefficient would be n4, 5 to the power n minus 4, and the minus 4 to the power 4, which gets us 256. So if you look at the clue given by the question says that the ratio between the x squared and the x4 term is 25:56. So I've put it down nicely in the notes, so you can do a comparison. So that means the x squared coefficient has 25 units, while the x4 coefficient is worth 56 units. So in order to make these two the same, okay, in order to make these two values the same, we are going to take the coefficient of the x squared term and we're going to multiply by 56, and we're going to take the coefficient of the x4 term multiplied by 25. Next, we are going to try to simplify this complex expression as much as possible. All right, so I start off on the left by splitting the 5 to the power n minus 2 into 5 to the power n in the numerator and then 5 squared in the denominator. Then I'm going to take the 56 multiplied by the 16 to get me 896. Then on the right side of the equal sign, I'm going to split the 5n to the power minus 4 into 5 to the power n in the numerator and 5 to the power 4 in the denominator. Then I take 25 multiplied by 256, and I will get the numerator 6,400. Okay, so why I do this, right, is because I will have a 5 to the power n on the left, and then another 5 to the power n on the right, which I can just simply cancel out. So I can get rid of this annoying term once and for all. Okay, then I pressed in the calculator to simplify the big fraction. Okay, so now I have consolidated all the terms into just a very simple expression, which is 7 over 2, n2 equals to n4. So we're going to address this elephant in the room once more. How do I convert n2 and n4 into tangible algebra form? So if you recall, n2 means that there are two things on top and two things below. So we're going to write n first, and we're going to decrease by 1 to get n minus 1 next to him. And then at the bottom, we're going to start with 2, and then we're going to write 1, which is 1 less than 2. Then on the right side, how do I expand n4? Remember, 4 means that there are 4 things on top, 4 things below. We're going to start with n in the numerator, decrease it by 1 to n minus 1, decrease it by 1 again to n minus 2, decrease it by 1 for the final time to get n minus 3. And then in the denominator, we're going to start with 4, then decrease by 1 to get 3, decrease by 1, and decrease by 1 again. So if you notice that there's a lot of things to cancel on the left and on the right. In the numerator position, we can cancel the n and n minus 1 on the left, and then we can cancel the similar terms n and n minus 1 on the right. Then in the denominator position, we are able to cancel the 2 times 1 on the left side, and then the 2 times 1 on the right side of the equal sign. So we're going to try to simplify as much as possible. We're going to try to trim as much as possible. Okay, so what's left is going to be 7 over 2 on the left, and then just n minus 2, n minus 3 over 12 on the right. So if we just cross multiply, we're going to get a very nice quadratic equation. We can solve it using the calculator, and we're going to get n equals to 9 and n equals to minus 4. So just a reminder, we are going to reject the n equals to minus 4 because in O levels, the power of n cannot be negative. All right, finally, guys, we're going to do the most common type 3 question. So the most common type 3 question is listed on the last page of my notes. And if you take a look at it closely, it actually resembles very similarly to a eyesight test when we were going through the type 1 style questions. So what did the question say? The question says that I have a bracket of half plus x squared multiplied by a type 3 binomial expansion, a 1 minus x over 3 to the power of n. And then after the teacher has expanded all of this for you, she gave you some clues. She said that upon expanding, we are going to get some terms like 1/4 plus kx minus 7 over 6x squared. So somehow this is supposed to be a clue to help us find n and k. And we begin as per normal. Since this is a type 3 question, we are going to take the binomial expansion with the power of n, and we're just going to expand it normally. All right, so I'm just going to expand to the first 3 terms. So why I expand to the first 3 terms is because the 4th term onwards, if you take a look at the algebra, is going to be an x cubed term. And the hints given by the teacher doesn't include x cubed. So I'm not going to bother by expanding an extra term, right, just to get something that I'm not going to use, okay? So I simply expand to the first 3 terms, and I took some time, right, to simplify all of these terms, right, into very nice algebra expressions, okay? So if you look at the second term, I converted the n1 into the algebra n, and then 1 to the power n minus 1 is simply not going to matter because it's going to be just 1. And then the last guy, the minus x over 3 to the power 1, I just put it at the side. Then for the third term, the n2, I've already converted it into algebra form. So it will be n minus 1 in the numerator, and then 2 times 1 in the denominator. All right, so the middle guy, 1 to the power n minus 2 is not going to matter again. And then the last bracket, the minus x over 3 square, I've squared it out for you to get x squared over 9. So this is not good enough, right? Whenever you do binomial expansion, right, it is a good habit to write out terms as coefficient first and then algebra second. So coefficient first and then algebra second. So for the second term, I've reorganized it to coefficient, the minus n over 3, and next to it, I put the algebra, which is x. Then for the third term, I wrote down all the coefficient on the left, so that would be the n minus 1 over 18. How I got 18 was because I just took the 2 times 9 previously. And then the x squared, which is the algebra, I just place it right next to the coefficient. Okay, so this is a very good habit. So now we have ourselves the expanded binomial. Next is to deal with the clue. So we are going to place the normal half plus x squared bracket next to our binomial expansion. Of course, we are going to expand it out first. Half plus x squared is simply just 1/4 plus x squared. So we are just going to do normal sec 2 expansion to get that. Then, what are the clues? The teacher says that the x squared term is minus 7 over 6. But how do we get the x squared term? We can take the 1/4 from the left bracket multiplied by the x squared term on the right bracket, which is n minus 1 over 18. Next, we can take the x term from the left bracket multiplied by the x term of the right bracket. So we take the coefficient 1 multiplied by minus n over 3. Last, we can take the x squared term from the left bracket multiplied by 1 on the right bracket. So all of this, right, will get us the x squared term. So we are simply going to write out the coefficient so no algebra is involved. And you realize that luckily for us, we only have n as our unknown. So if you simplify the algebra using common denominator, you're going to get a very nice quadratic equation, which you can just press in the calculator to get n equals to 12 and 13. So we're not going to reject any of these numbers because there's no negative n. Okay, so we're going to take both. Next, we're going to compare the x term. So the x term given by the teacher is k. The coefficient of x term is k. But how do we get the coefficient ourselves? So we are going to take 1/4 on the left multiplied by the x term on the right, which is minus n over 3. Then we're going to take our x term on the left multiplied by 1 on the right. So that would give us the x term exclusively. So when we do so, we are going to get k equals to 1 quarter multiplied by minus n over 3 plus 1. So remember, we did not take into account any of the x, so don't put the x in your working, okay? Because that is just added complication. So once we do this, we are going to substitute the two n values from before into our expression, and we are going to get a k value of 0 and a k value of negative 12. So why do we reject the k value of 0? Because if you read the question says that k cannot be equal to 0. So what that means is we're going to outright reject k equals to 0, and we're going to reject n equals to 12 because that's what led to the k being 0 in the first place. Okay, so congratulations guys, this is type 3.